Right, hello, welcome back to another video. This week we're going to be having a look at how to do a spiral shader with world position offset. So this is an example that someone actually tweeted me about, asking for a breakdown, and I don't think I've gone exactly the same method as they have here, but we've got somewhere close, and there's some really interesting things happening in the building of the shader, and then especially in the shading as well, in the actual normals. So this is a really good example of a cool effect here at the start of this fighting game. Thing scrolls down and scrolls back up again, and it's all just done using sort of vertex animation in the shader. So let's try and build this up ourselves. So here's where we've got, and we'll have a talk about the different sort of options we've got here, but we're getting something similar. The shader sort of doing the rotation and then scrolling up and down. Obviously with this, there are a lot of other options you could have used. You don't have to do this with vertex animation in the shader. It's actually quite complex to do it that way. Might be better off just using this sort of simple skeletal animation or sort of vertex animation texture, something like that. But it's a nice problem to sort of try and solve. So let's give it a go. Let's start with a brand new material. I'm immediately going to set my preview mesh. So if we just use this initial plane here, that's fine for some kind of previews that we want. But if we have a look in wireframe view, you can see it's not really got any geometry. It's just a 4x4 kind of gridded plane. Don't know how easy that is to see here, but actually we need a bit more geometry to do this. Anytime we're doing things with well position offset, you need the shader, or you need the vertices in the model, and you can see that in the example here. It's very highly or very dense, kind of like breakdown on the different kind of parts here. So so rather than using the default plane here, I'm actually going to go down to the preview mesh and type in planar reflection plane. So this comes with the engine. It's great. You can see that it's 2048 triangles, so it's a really high res plane, which is great for sort of previewing kind of any vertex position offset stuff. So just make sure you're using the right preview plane for this. Not going to worry too much about the color and the appearance of the actual thing for now. We're just worrying about the animation to start with, and we'll just set some sort of mid-gray, something like that, to make it not quite so dark and difficult to see. So what we're going to be doing is using the rotate about axis node. And what this does, takes in some input values and works out how to rotate the object, or how to rotate the vertices to create rotational motion. Really useful for doing well position offset type things. Needs a few inputs. So firstly, the rotation axis. Well, I'm going to do this all in world space to start with, and we can convert to local space later if we need to. So I'm just going to use the red axis. So we're going to be rotating around this point here, or this axis, kind of into the screen. The pivot point. Well, I'm actually going to plug in a parameter for this, pivot, and then manually tell it where I want to rotate around. So quite often you're rotating around the origin, and you can get the values for the origin. I did originally. The bounds, local bounds. Did originally do this with the local bounds, which would find this edge for us really nicely, which is where we want to rotate around. But that interferes with the bound scale in the engine, and we'll see that in a bit. So instead, we're just going to manually kind of tell it where we want our rotation to happen around. Position here is what vertex are we currently sort of querying or moving. And so we just plug in the world position node, and that will tell it to sort of like move these verts a certain way. And then finally our rotation angle. This is our how much are we rotating them. So if we just do a time in here, what we'll get is our plane will spin around the center point. And I'm just going to turn on two-sided because we're going to want this to be a two-sided shader. So that's what a rotation about axis does. Again, really useful for doing kind of rotational movement in vertex animation. Not very spirally. Well, that's fine. We can fix that. So the first thing I want to do though is move the pivot. So rather than pivoting around this center point, I'm just going to put a value of minus 500 in Y, because that's, I believe, 100 or 1000 unit plane, and now we're getting rotation around the edge. Now if we think about spiral, the points closest to this edge don't want to rotate very much, and the points furthest away want to rotate quite a lot. And so rather than just using time as an input, if I take a text chord node, and then I'm just going to mask out the green channel. If I just plug that in, let's see how much that works. You can see the bits that are close to the edge, or close to this pivot point, have rotated a little bit, and the bits that are further away have done a full rotation. And that's going to be the sort of the basis of building up our spiral shape. Now if we want more than one spiral, well, here the values go from 0 to 1. If we just multiply that by a value, I'm going to make the parameter, call it spirals. That will let us have multiple spirals here. So if I do 3 or 5, you can see we're getting more and more spirals. Notice what I was saying about geometry. So even though this is quite a dense plane, we're still getting some really hard edges in here. If it was more geometry, if there was more input data to work with, more vertices, you would get a better, smoother result. So, so I'm just going to stick this down to 3 for now. Somewhere okay, it's smoothish, not too smooth, but smooth enough, and that will give us our kind of spirally effect. That's cool, right? But we also want to be able to sort of control this, change from being a spiral to being a flat plane. So what I'm going to do is just create a lerp, and then I remember how I did this before. So if my values there is set to nothing, and actually I'm not going to use a parameter for now. I'm going to use the debug time sign. It's really useful little debug node. It's just values that kind of oscillate between 0 and 1. This is going to be animated. I'm going to want to animate this later on, and we can do this with a parameter and change everything. But for now, I'm just going to change this to be using the debug time side node, and I'm going to plug in a speed control as well, just slow that down slightly. Now this is sort of doing what we want. We have our 2 endpoints the same, but not quite right. As you can see, it's a linear movement, so it's linearly changing from the spiral shape to the flat shape, which isn't really what we want, but we can work with this. And so what I'm going to do, the same values that I'm using to sort of blend between my 2 shapes, I'm also going to use to blend how many spirals I've got. So if I multiply my number of spirals by my animated value, we get something that's starting to work a little bit better. So when it's set to 0, we've got no spirals, it's all flat, that's nice. But when it's curled up, we get something that's fully curled. And there's a little bit of transition happening here, where it's still not quite working. If it was quick enough, you could maybe see that it was sort of hiding that error. But there's some weird kind of transitioning happening here. And what I'm going to do, rather than just blending the whole thing at once, what I effectively want to do is create a mask that starts at the bottom, and then the bottom bit starts to transition, and as it reaches the top, the whole thing will be transitioned. And so it's kind of happening along the thing rather than the whole mesh sort of transitioning at once and spiraling at once. So to do that, again, I'm going to use the UVs as a mask, and I'm just going to take that, and rather than just blending those 2 things together, I'm going to subtract this value. So when this is value of 1, we're going to get pure 0 in here, pure black, and that's going to give us a slightly better sort of result for this. Ooh, make sure it's the right way around. That looks like it's the wrong way around. So if I just 1 minus this, well, one problem we've got here, if I just preview this node, so we should be getting white, and then our black mask should come up. Let's maybe a little bit slow. Well, the amount we want is to go from pure white to pure black, so we're not subtracting enough. So if we double that, in fact, rather than doing that, let's use a lerp. So I want to make sure that the amount that I'm animating, or the animation happening here in the debug time side, doesn't just want to go from 0 to 1. I want to go from maybe 0.5 to 0.5, just so that I'm kind of getting all the way black. No, so let's do -1 all the way to 1. So we're getting pure white, scale down and back, pure black. And that's the sort of the effect that we want here. And just remember to clamp your values before they go into the alpha of your lerp, otherwise you're going to get sort of overcompensated animation. Starting to get somewhere, not quite there yet. One thing, again, if we preview this node, we've got a full gradient. We don't want a full gradient. We want the change between the spiral part and the flat part to be really high contrast. And so I'm actually just going to use the cheap contrast node in here with a value of something like 5. Let's have a look at that. Oh. Well, starting to get there. A few issues. Obviously, we can see it's not really connecting with the spiral correctly, but we're starting to get there. Now, one thing you might notice, the spiraling effect that we're making is making the plane longer, that rotation effect. So we also want to kind of artificially make the other plane, the flat plane, longer as well, to make it kind of look together like they're sort of the same sort of conservation of volume or conservation of shape. And so in our flat condition, this one here, I'm actually going to move the verts. So the bottom line, I actually want to move along the y-axis to be that little bit longer. And so how do I do that? Well, if I take my mask again, just make sure it's the right axis. Well, yeah, so I'm going to use that to duplicate here. And I'm going to multiply by the green axis, and then multiply by a value. And what that should hopefully do, if I plug in something like, say, 500, you can see the length of our plane has got longer. Something's not quite right about this. I'd say it's quite a tricky shader to do. So I think one thing that's happening is our spiral's going the wrong way, and we're kind of blending one side incorrectly. Swap that round. Oh, that's definitely wrong. What happens if I just invert my spiral here? There we go. So the end of the spiral goes down, and we'll fix the sort of the connection points in a minute. But this length doesn't want to snap to full length, so our value here, going from 0 to 1, also needs to be part of this component of this input. So if I just multiply that in as well. So you can see as our spiral happens, that's the wrong way around. Let's do 1 minus. And there are a few what I would call magic numbers in this. It's kind of tweaking it until it works, until it sort of looks right, and that's starting to work a little better. So as the spiral comes around and forms, the plane snaps down. Cool. So let's fix the next bit. This spiral, it's twisting from the center. Well, if we've got our mask here, and let me just turn off the animation for a second. And then turn off the animation for a second. That's controlling our sort of spiral shape and how that works. If we add a value to this, and I'm going to add it after the multiplying. You can see how the start of the spiral, or the sort of the end point of the spiral, has moved. So we can control where that spiral is. And so to make this kind of look right, when we have the animation in here, I'm going to put that back. We want our bit that's coming from the flat plane to always look like it's in the right place. So here at the start, it kind of works. That value there looks like it's bending around, but it very quickly becomes the other way. And you can see that there. So this needs to spiral around over the course of the animation. So again, we have our animation value here, and we're going to just plug in a lerp and tell it at the 0 point I want the animation to be a certain place, and then at the other place, at the other point, the 1 point, I want our animation to be there as well. So it's starting to work. You can see it's curving round, and then it just curls around a little bit too much at the end. So if I increase the amount it's curved, and there is quite a lot of just fiddling with the numbers with this shader here. It's difficult. You could maybe try and do a load of trigonometry and work it out exactly, but I'm very much of the just plug the numbers in until it looks like it kind of works approach. And there we are. Maybe start a little bit, oops, 0.2 maybe. Okay, 1 second, that's my doorbell, real life sticking in. I'll be back in a second. Okay, right, apologies for that. Where were we? Yes, so we've got our mask or our animation working. And obviously, like I say, you can tweak these numbers to get that to the result you want. And one limitation is this: it is kind of just magic numbers that work. So maybe that's too much the other way. Can be a little bit fiddly. There's obviously a lot of numbers controlling this, but you can, with a little bit of playing, get a result that works quite nicely. Unfortunately, these magic numbers in here do correspond specifically to that spiral value, and so changing the sort of number of spirals, you will have to change the magic numbers that go in here as well. I did have a investigate, couldn't find a kind of nice connection between the two, unfortunately, but maybe your luck will differ and you'll be able to make that work. But it does work quite nicely for kind of that transition from one thing to the other. Cool, that's the sort of spirally well-positioned offset side of it. As I say, it's probably not the only solution to do this, but it's one that does work quite nicely. And we're blending from that long shape down to the other one. There's a little bit of a sort of strange kink in the sort of transition, and you may be able to just blend that out either with slightly lower contrast. That's working a little bit better, and just making sure that the length that we're kind of artificially extending it to corresponds to our kind of like amount of spiral as well. Remember, we've plugged in a plane to this, but actually what we're making is quite rectangular, kind of long and thin. So there's maybe some changes you can make in different sort of input shapes as well. Now, where this then gets a little bit more interesting is with the shading. If we have a look in here, this is the one we've just made. I plug that in. Ooh. Ooh. So what's gone wrong here? Well, let's fix this first. The values I've used here for my axes and my direction are all in world space. So we're rotating around the world x-axis. Well, that's fine, except when we're not. So I'm just going to transform everything into local space. So from local to world here, into this one, transform again for the this direction vector here, so that we're always moving in the local Y for that kind of artificial extension that we were getting. And there. And this one we want to transform, but this is a transform position because it's a position that we're using instead of a direction vector. That should now be right, and everything should be in local space. Sometimes a bit tricky to work with local and world space. The viewport window, local and world are the same, and so there's no difference in here. But now, if I go back to the world, this is now working correctly. And you can see as I rotate this around, it's always doing everything in local space, which is probably what you want. Cool. So this is the one we've just made. As I say, I'll just swap back to the red one that I have from earlier. And let's have a look at the normals. So let's just hide the other three. Whoops. Hide the other three. And this is just a mesh spiral that I made in Maya, imported as a sort of reference for these kind of normals and shading. You can see the shading's a bit wrong. So one of the limitations of world position offset, it only moves the vertices, it doesn't actually update any of the normals. And if we go here into buffer visualization, world normal, you can see, if I just create a plane, just going to do a flat shader on this. This is our kind of unanimated or undeformed plane, non-deformed plane. And so the normals saying this bit is facing this direction, yeah, this bit is facing this direction, and as we rotate them around, it's not updating them at all. So we're getting really flat shading along our on our spiral. Very common issue with world position offset. If you're doing little bits of movement, you can kind of get away with it, but we're asking quite a lot here of our spiral kind of shader. So few options we can do to solve this. Firstly, if we have a look at the sort of initial input or reference here, I think this is actually an unlit shader. If we have a look in the world, it doesn't look to me like it's taking any lighting information, so I think they've actually just baked lighting into that. Totally valid solution. It's going to work really well. You're not going to have to worry about your normals because you're doing it unlit. And in this case, there's a very controlled environment. This is never going to appear in shadow or in light or anything like that. It's just going to appear there floating. So magic spell things, this will work quite nicely. But we can maybe have a go at making some normals, because it doesn't look like there's any shading up on this. So so how do we do this? Well, there is a node. I'm not going to go through all of them, but if I unhide these, there's a few options we can do. So this one, if I just open it up, there is a material node, rotate, fix, rotate about axis normal. So whenever you're using the rotate about axis node, you can also use this one together, fix, rotate about axis normals. And the way this works is very similar to the rotate about axis node. So the same inputs, you can see here, axis, what's it called, normalized rotation axis is the same, the rotation angle is the same, the pivot point's the same, and all I'm doing is using another lerp, and I'm blending from the fixed rotation normals when I have the spiral, and then the original vertex normals when we have the flat plane. Note, I'm using a two-sided sign here because it's a two-sided material. The vertex normals vary differently on the two sides of the plane, so we're just adjusting those normals. One more thing to note, this is using the world space normal, and here vertex normal WS is also world space, and so in our shader we need to disable tangent space normal, so this is normally enabled by default, and we can turn that off and we'll get a slightly better result in our shading. So this second one here, you can see we're getting shading along on this sort of spirally bit, and shading down here, and backside. Not a bad result for for this sort of approach. We do check the world normal buffer visualization though. As we get here, there is a big seam along the bottom. I'm not entirely sure how that function is doing that and calculating the normals, but it is giving you an error. There's a big discontinuity here, and if I go back to the lit mode, you can see that in our shading as well. There's an error along that bottom face, which isn't ideal, but depending on your use case, you might be able to hide that with a shadow or some kind of shading or glowing or something, but it is giving us a result. That's one way to work out our normals. We have a few others. So I have what I've called here my world position offset calculated normals. So this is a little bit more complicated. If you're interested in this kind of technique of calculating normals in the shader, I did make a video about it in terms of sort of landscapes and flat materials. In this case, we're asking it to do quite a lot. So the that should be connected. Okay. So the principle here, if I jump back over to a little diagram, if we draw a spiral, roughly, the idea is that if we've got a few positions along our spiral, we can calculate our normals. And so if we have a position here, and then a position slightly across, we can work out this direction vector, kind of like along our spiral, or the other way around, I guess. Not that it makes any difference. And then we know that our spiral, the axis, if I change to red, the other axis is sort of through the spiral this way. It's not very good 3D drawing. But we can take the cross product of those two, and what that will calculate for us is our other orthogonal vector. So because we know our spiral is a cylinder, or our spiral is quite tubular, we know one of our axes, we want to calculate this direction vector, and then we can work out our last one with the cross product. And so what we do is if we take our initial spiral, our deformed spiral, and then we do a very slight offset, and so we calculate the same spiral, same geometry, same math to do this spiral sort of deformation, but with a little bit of extra movement. We can calculate these 2 points. One point minus the other will give us the direction vector between them. We can normalize that, cross it against the other axis, and we should get our normal. That's the theory, and it sort of works, but we'll see there's a couple of issues I don't really understand. So if you do see the flaw in my method here, and can kind of like help me correct this, that would be great. Please leave a comment or send me an email. But what we're doing is we're taking our initial text chord input. This is defining our spiral. We're adding a very small offset. So here it's, what's that, 0.0005, and we're doing the same logic to it. So same offset here, same number of spirals, same animated values at the bottom, into the same rotation, and then we're just taking one position minus the other, normalize, cross against the sort of the red axis, and that should give us cylindrical normals, or sort of calculated normals. And if we have a look, again, if we go into our, well, we have a look at the shading, it's sort of working. The bit that is in light is lit, the bit under here which is shaded, but we're getting kind of a double result, which I don't quite understand. So it's ignoring the fact that this is kind of on the back face and not calculating that correctly. We have a look at our world normal. It's definitely doing something. Here, this sort of front face kind of looks similar, but then, like I say, underneath and maybe around the back, this should not be this angle. Approach that I thought would work, unfortunately does not. Like I say, if you have any ideas about that and you can kind of work out what's going on with that, please do let me know and I can do a follow-up video. But there's one more sort of way of calculating normals, which is actually a little bit simpler. So if we take our spiral, if we just assume that our spiral is, delete all this, is actually a cylinder, which for most cases it is. It's not quite exactly cylindrical, but it's pretty close. If we take a point along the surface, let's say here, and our center point, we can actually just take that direction vector there as our tangent, as our normal, and so each point is going to have the normals facing outwards, and so you can procedurally calculate kind of like a cylindrical set of normals very simply using the object center point and the edge, and so that's what I've done in this last one. This is the cylindrical normals, just the object position, so the outside position, or the current vertex position, the object position, which is that center, and I've multiplied them by 0, 1, 1, so I've just zeroed out any x component. So if we left this at 1, 1, 1, that would give us a full spherical set of normals, and if I just apply this, we can see when that loads in, you might be seeing the highlight sort of a spherical point, and you can see it kind of comes down to a point here at the end as well. Well, that would be a sort of calculated spherical normal, but to do it cylindrical, because our cylinder is along the x-axis, if we just zero out any x component, that will give us cylindrical normals along our spiral, and that's giving us this result here. So shading at the bottom when it spirals up, shading at the top. Each of the spirals looks sort of decent. We are getting a shading error here in the transition between the two. Unfortunately, there's quite a lot being asked of it to do between the two sort of types of shading. We've got the flat shading and the dark shading, so that's again a problem I've not been able to solve, unfortunately. But yeah, maybe you can kind of adjust the numbers a little bit and try and hide that error there a little bit. But yeah, as a result, I think I'm pretty pleased with that. It's got the shading, sort of the spiraling motion that I wanted. Obviously, we could use just an unlit shader to do this. We're looking at a kind of magic scroll effect, so we can always just add some kind of emissive glow that helps to hide out the shading errors that we're getting. But some interesting results there in the 3 different types of kind of calculated normals, either using the built-in fixed rotate about normals, gave us a nice result, but with one large discontinuity. Not quite sure why. I'd have to have a look at the math inside there to see exactly what it's doing. But it's all being done in a custom node, is it? It's just rotating the normals. Yeah, not a topic for today's lesson. But where are we? Yeah, so the fixed rotate about axis normals gives us an okay result, but yeah, with that large discontinuity. The calculated normals, which I think should work, not quite sure why they don't, give us sort of a double result, strangely, but actually the cheapest, or the sort of the quickest and easiest, is just to approximate to a cylinder anyway, and that gives us a pretty good result for sort of artificial fake shading. Cool. Hopefully that was helpful and informative. As always, if you've got any questions, please do get in touch. Big thanks to my patrons for supporting the channel, and I will see you all next time.